Hi and welcome to another one of my videos that takes you through the word solutions to the different practice booklets that we're giving you. This one is for booklet number 3, that's what I'm calling it, and it's set 1 paper 3H, so it's the last paper of set 1. It's a calculator paper, so make sure that you use a calculator on every question you can. Don't feel bad about using a calculator. The questions are designed with the expectation that you're going to use a calculator, so make sure that you use it. You don't get any more marks for not using a calculator, you just run out of time and make more mistakes, so please do that. Like I said before, sorry to keep on saying this, use this help to help you in the best possible way. If you come to a question that you can't do, if you want to see some help on a question that you found difficult when you did the homework, don't just copy from this video or from the work solutions into your booklet. Those work solutions, this video is available for you at any time, so it makes no sense to copy the notes in because you've got them whenever you want to look at them. What's important is to use that help to try and understand. So when you come to a question, don't write anything and just concentrate on listening to the video, watching it, reading the solutions, and trying to understand for yourself how to do it. Once you've done that, turn the video off or pause it, close up your answer booklet, and then you get your question booklet and then you try and do it from what you remember and from what you understand. That's a completely different process to just copying from one thing to another. That won't help you. Okay, right, let's get on with the questions. So question 1, it's really important that you must show all the stages in your working. So it's really important that you say the angle fact you're using and the steps you're using. So you've got to understand how to label angles. For example, this angle here is angle QCA or angle ACQ. This angle here, for example, would be angle ABP or angle PBA. And it's really important you use that way of labeling angles. You've got to use the kind of skills that you knew back in year 7. Angles on a straight line equals 180, angles in a triangle add up to 180. And you've also got to use certain angle facts that you know with parallel lines. First of all, whenever you see parallel lines, you should be looking out for Z's and you should be looking out for F's. Okay, now here is an F. If you think of this line here, these spokes or this line's going up here, we've got an F lying down on the long side. So that angle there and that angle there will be the same because they are F angles. Now this being in maths, you've got to be precise. You can't put down F angle. You've got to remember the mathematical phrase. So it would be corresponding angle. And you need a way of remembering how an F angle is a corresponding angle. My particular way is that F stands for facts, and the facts is a way of corresponding with someone. Okay, another teacher's way is that F stands for fish, and fish lives in ponds, and you've got corresponding. Okay, it's whatever way works for you to remember it. In the same way, you should be looking for Z's, and I can see a Z here. Can you see? Here. And this Z tells me that this angle here is the same as this angle here. Okay, but you mustn't say a Z angle, you must say alternate angles. Okay, and alternate angles, how do I remember that? Well, a zebra has got alternating black and white stripes. So Z for zebra and alternating stripes. Okay, so how would you set out a question like this? What you mustn't do is just write down the answer. If you write down the answer, you won't get any marks. You've got to put down, it says, give reasons for your answer. So step by step. Now in all these questions, there's often different ways of doing it. So here's one way. Corresponding angles on parallel lines are equal, so we know that this angle here, angle DCQ, is equal to angle PBA because they're both F angles or corresponding angles. If you know what this angle is and this angle is, this angle here, angle ACP, that must be 50 to add up to 180 degrees. So once again, angles on a straight line add up to 180. And then once you've got this angle and you know this is 90, you subtract them from 180 to get that angle. What angle fact did you use? Angles in a triangle add up to 180. So you're just writing down here the angle fact that you used to work it out. If you just work it out but don't say the fact, you don't get the mark. So it's really important you don't throw away easy marks. You don't have to do it that way. You could, for example, say that this angle, angle QCA, is equal to this angle here, angle CAB. It must be 76 because it's alternating. Well, if this is 54 and this is 90, you can work out what this angle is. Okay, what must that be? It must be 36. You double check with that? Yes, 36. Okay, and if that's 36 and this angle here is 76, then this angle here must be the difference, and once again it's 40. So you'll always get the same answer, but there are often different ways of working it out. Okay, any way is fine as long as you say the reasons and the angle facts you used. Jenny is organising a party. She buys some paper plates and some plastic cups, and they're sold in packs of 25 for the plates and 35 for the cups. So your plates can only be in multiples of 25 and your cups can only be in multiples of 35. And she buys exactly the same number of plates and cups. So basically you're looking for a number that is a multiple of 35 and a multiple of 25. And all you need to do is just write out your lists, your multiples of 25 and your multiples of 35, and the first number you get that's in both lists is what you want. It's 175, and from this list you can see that 175 is 7 lots of 25, so that's 7 packs at 78 pence each. That costs that. And 175 is 5 lots of 35, so that's 5 packs at £1.10. There you go. Add it together and you get that. If you put down a different number here, or obviously it'd have to be the same number, but if it wasn't 175, but you still did this bit here, you would get the marks. So actually, if you didn't get 175, say you had 350, which is also works, but it's just a bigger number. You want the least amount. But suppose you put down 350, but you did everything else correct, then you'd only lose 1 mark. You'd only lose the mark for getting this number here. If everything else was correct, you still get 4. So it's really worthwhile showing you're working out. There are only red beads and green beads in a bag, and the ratio of red beads to the number of green beads is 5 for every 9. 5 red for every green, 9 green. Okay, what fraction of the beads are red? Well, it's not 5 out of 9. That's a common mistake. If 5 red go with 9 green, then there will be 14 altogether. And the fraction that are red would be 5 out of 14. So there's your fraction. Now, there is a total of 84 beads in the bag. How many of the beads are green? Well, if the fraction is 9/14, then it's going to be, because if it's 5/14 for the red, it's going to be 9/14 for the green. Okay, so you find 9/14 of 84, and that's 54. So there are 54 green. She's going to put some more beads in the bag. There will still only be red beads and green beads, and she wants to have twice as many green beads as red beads in the bag. What beads should be put in the bag? You must explain your answer. Well, we've just worked out that there are 54 green beads. And if there are 84 beads altogether in the question, and 54 green, then 30 must be red. So if we want twice as many green as red, and we've got 54 at the moment, we need to add another 6 to make it up to 60 green, which would be double the 30 red. The table shows some information about the average adult spending in 2008 as a percentage of total adult spending in 2008. In May, Katie spent a total of £425 and she spent £48.45 out of that money on food. Compare the percentage that Katie spent on food with the average adult. Well, the most common way of doing it is what's been done here. Okay, it's going to be 425 out of 4,845. This fraction's upside down. And then you times it by 100 to make it into a percentage. And that gives you 11.4%. Now, the average spending you can see is 11%, and she scored 11.4%. So you just got to make a comment. It says compare, which means you need to put a comment in. Now, you can spin it both ways. You can say it's pretty much the same as average. The average adult spending food was 11%. Katie is above average and spends more. Yes, she spends more. Okay, fine. That gets a mark. You could also say it's only 0.4 extra. It's about the same as average. Her spending is about average. As long as you make a reasonable comment, okay, based on the figure you've done here, then you'll get the mark. What someone else did is they found 11% of 425 and said, okay, well, if Katie was an average person, what's 11% of that? Work it out and then compare it to what she actually spent. That's a different way of doing it, and it's perfectly fine. As long as you make a comment here, you'll get all the marks. Coventry Estates sells houses. In February, they sold twice as many houses in January, and in March, they sold 10 more houses than in February, and in April, they sold half as many houses as in March. Coventry Estates sold a minimum of 123 houses from the 1st of January to the 30th of April. Find the least possible number of houses sold in January. Now, look, you've got 5 marks here. It's worth having a go at this and doing something here. Okay, if you don't do anything, you won't get anything. So have a go. Now, this shows you the connection between what they sold in one month and what they sold in another. Now, you know that they sold a minimum of 123. So you could try and solve it without algebra. You could say, if you couldn't use algebra, you could say, okay, well, let's try, let's see if they did 20 in January. Pick a number. If it was 20 in January, okay, then February would be twice as much. That would be 40. March would be 10 more houses than that. So that would be 50. And in April, they sold half as many houses as in March. So that would be 25. And you could add it up and see if it came to 123. And depending on whether it was more or less, you could just tweak it and change another value for January. If you couldn't think of anything else to do, that would work, but it would be a bit slow. Let's try and solve it with algebra. Okay, now we don't know what it was as in January. We don't know what they sold in January. So we're going to put down a letter X. Okay, you could put down a J for January if you wanted to. And February, they sold twice as many houses as in January. So whatever that is, that's twice as big. So it will be 2x. And in March, they sold 10 more houses than in February. So whatever that is, March is going to be February, that's 2x, add 10. And April is half of what March is. So that will be half of that. And let's simplify that straight off. Half of 2x is x, and half of 10 is 5. So if you put down 3 of these, you're going to get yourself a mark. Okay, it's worth having a go. Now, what do we know? We know that the total is at least 123. Okay, because it says a minimum of 123. So let's find out what that total was. It's going to be 2x, add 2x, add 10, add x, add 5. So here it is there. So this line here is just these added together. And that's got to make at least 123. Once again, a mark for doing that. Then you're going to gather things together. You're going to gather your x's. 2x and x and 2x and x makes 6x. 10 and 5 makes 15. So 6x plus 15 has got to be bigger than 123. Now you're going to solve this in exactly the same way as you would do an equation. So however you solve 6x plus 15 equals 123, solve this in the same way. Take 15 from both sides, you get 6x is bigger than or equal to 108. Share both sides by 6, and you get x is bigger than or equal to 18. Okay, don't forget you can use a calculator, so 108 divided by 6 is easy. Don't try and do it in your head, do it on a calculator before you make a mistake. 18 is the answer. Okay, it's the biggest, I beg your pardon, it's the smallest number, okay, that they could possibly have solved and got the total up to 123. So 18 is the answer. Look at the marks you've got for the steps here. Okay, so it's really important you show those steps and you have a go. Question 6. The diagram shows a circle inside a semicircle, and we've got to work out the area of the shaded part. Now, if you can find an area of a circle, then you can find the answer to this question, and once again, show some steps. So how would you describe what you see here? Well, this area here and here is what you get when you have half a circle and you take away a small circle. So, or you could look at this bit and say this is a quarter of a large circle, take away half of a small circle, and just look at this part. Okay, so you need a plan, and that's what it says here. Find quarter of the big circle and subtract half of the small circle. Okay, so what's the area of a circle? It's pi r squared. What's the radius? Be careful, it's not 20, that's the diameter. So the radius is 10. 10 squared is 100, times pi is your area. And you can see that they've written that down, and then they've written down as an answer. So 314.15 blah blah blah, working nice and accurately, is the area of the whole circle. But we just want a quarter of the circle. So once you've got an area of the whole circle, divide it by 4, and this answer here is going to be the area of this piece here. Okay, once already you've got 2 marks for doing that bit so far. Then you want to find the area of the small circle. Okay, the radius for the small circle is 5. So pi times 5 squared gives you 25 times pi. Work it out as a number there, and then half it, because it's only half the circle missing. Remember, we're confining ourselves rather to just this piece here. Okay, so we half it and we get that there, another mark. Finally, we subtract this part, which is what we just worked out, from this answer, which is the bit we worked out here, and then you pick up another mark. Okay, one more mark for doing it in 1 decimal place. So if you can find the area of a circle, you can do this. Okay, it's worth having a go. Look, even working out half of that, half of the big circle, and just doing that gets a mark. Okay, when you only need, say, 20 out of 80 to get a C, every mark is really valuable. Don't throw them away. Ali was asked to solve the equation. Here is his working. What mistake did he make? Now here you've got to be really important. You can't just say 3 times 4 is 12. You've got to actually say what is the mistake. And the mistake is when he expanded the bracket, he did 3 and the 4 and added them. And he should have multiplied. So you've got to say what the mistake is. You can't just say what the answer is. You can't say 3 times 4 is 12. Okay, yeah, I know 3 times 4 is 12, but what's the mistake? What did he do that was wrong? That's the bit you've got to say. Okay? Much better to explain too much than not enough. Another nice easy mark in the bag. Sam invests £5,000 at 2.8% per annum compound interest for 4 years. Don't forget you can use a calculator. So, if you're going to increase something at 2.8%, then your multiplier is going to be 1.028. So 0.028 is the decimal for 2.8%, and 1.028 is what you would multiply by to increase by 2.8%. So 5,000, because that's what you started with, multiplied by 1.028 for every one of those 4 years that money was in the bank. So 1.028 to the power of 4. Use your scientific calculator. There's your answer. And then finally round off to 2 decimal places because we're talking about money. Okay. Once you've got that idea of multiplying, it's just doing the same thing here but in stages. So 2% in the first year, so it gets multiplied by 1.02. 3.5% for the second year, so whatever you had after the first year gets multiplied by 1.035. Okay, and then whatever that is gets multiplied by 1.05 for the third year. Once again, don't forget to round off to 2 decimal places. Okay, a rectangular lawn has a length of 3x meters. Here it is. Okay, and a width of 2x meters. The lawn has a path of width 1 meter on 3 of its sides. The total area of the lawn and the path is 100 square meters. Show that 6x squared plus 7x minus 98 equals 0. Right, so what you've got to do first of all is you've got to work out the area of this particular face or this shape, the total of it, in terms of x. Even if you can't do this bit here, do that part. It's going to get you some marks. So, how can we do that? Well, we know this bit in the middle is going to be 3x times 2x, and that's 6x squared. Then what you could do is break this shape here into 3 rectangles, okay, and you can see the dotted lines across. So this must be 1 because it's 1 down here, and this is 2x, so this is 2x square meters, and this will also be 2x square meters. Okay, and this, well, this is 3x, and this is 1, and this is 1, so this length is going to be 3x plus 1 plus 2. 3x plus 2 times 1. So it's 3x plus 2 square meters. So you've got 6x squared plus 2x plus 2x, which is 4x, plus 3x is 7x plus 2. So 6x squared plus 7x plus 2. And you know that that's equal to 100 because it tells you that the total area of the lawn and the path is 100 square meters. So whatever x is, you know that 6x squared plus 7x plus 2 is 100. Just before I go any further, you could do it in a different way. You could say, okay, well, this rectangle is 3x add 2 long, 3x plus 1 plus 2, and it's 2x plus 1 wide. So to work out the area of this shape, it would be 3x add 2 in brackets multiplied by 2x plus 1 in brackets. And then when you expand those two brackets, you would get exactly the same thing here. Just a different way of doing the same thing. Okay, now when we're solving some quadratic equations, we want them to be equal to 0. So we don't want this number over here. So we subtract 100 from both sides. If we take 100 from here, we've got 0. And if we take 100 from here, we no longer have got 2, but we've got minus 98. 2 take away 100. And there we go. We've proved that 6x squared plus 7x minus 98 must be equal to 0. Now we've got to work out what x is. And you can see here that the teacher has used the quadratic formula, if some of you got onto this and some of you haven't. As a little tip, we're only on question 9. Okay, and this formula here is usually used for the A star kind of stuff, and we haven't really got onto the A star stuff yet. So it's a big hint that probably this quadratic equation will actually factorize. We're going to get the same answer, but we could use this, and sometimes using this is easier or quicker. But if we're on question 9, the big hint, or my feeling is, it should factorize, and I can see that it does. Okay, this quadratic equation will factorize. 6x, beg your pardon, 3x times 2x gives me the 6x squared I need. 14 times minus 7 gives me the minus 98 that I need. 2 times 14 is 28. Minus 7 times 3x is minus 21. 28 minus 21 is 7. So I've factorized it. Okay. Now remember what you do when you have brackets equal to 0. You set each of the brackets equal to 0 and work out what x must be. Okay, so either that bracket is equal to 0, so 3x plus 14 equals 0, so 3x must be minus 14. Divide both sides by 3, x is minus 4.666, or this bracket must be 0, 2x minus 7 equals 0, so 2x is 7, and x is 3.5. Now, we've worked out the answers there, and we're going to get some marks for that. We've got to choose what's a sensible answer. We're looking at working out what the length or what the value of x must be. And in this particular problem, it doesn't make sense for x to be negative. So we're not going to use that. We can't have a negative length. And so we just take the one answer here of 3.5. So we now know that x is 3.5. Now we know that x is 3.5. This will be 2 lots of 3.5 plus 1, 4.5. Okay? And this length will be 3 lots of 3.5, which is 10.5, add 1, add 2, 12.5. And multiplying those two numbers together will give me the area of the lawn and the path. Okay? Oh, area of the lawn. Oops, I've made a mistake. Okay, rewind. I just did the area of the lawn and the path. I didn't read the question. There's a not following my own advice. Sorry, folks. Okay, one more time. We've just worked out that x is 3.5. It's easier than I said. Here's the lawn. Don't do the lawn and the path like I did. That is 2x. Okay, and that is 3x. Okay, so 3 times your number there, 2 times your number there, multiply them together, and you get 73.5. Okay, now here you've got to work out what the missing numbers are. So the missing number there would be 3 squared, 9. Take 4 times 3, which is 12. 9 take 12 is minus 3. Take away another 2 is minus 5. Okay, I really recommend you do it like they've done here, and you do it in bits and you take your time. Okay, if your dots don't make a symmetrical pattern, that's a big hint that you've made a mistake. So if when you go on, you plot these points and they're not symmetrical, the big hint is that you've made a mistake. Now can you see, look, negative 6 and to the side, minus 5 and minus 5, and then minus 2 and minus 2, and then 3 and 3. So actually, another way of working out what this could have been is just to use the symmetry in the numbers you see. Minus 6 and then working out, minus 5 and then working out from the side, minus 2, and then this one should be the same answer as this, and it is. Okay, now when you plot them, it's really important that you correctly plot them and you draw a smooth curve that goes through the crosses. Okay, not something that kind of skirts in and out in between. Okay, it's got to go through them. And the reason that is because afterwards you're going to use that graph to work out the answer. And if your graph is wrong, you won't get the marks. So it says use your graph to estimate the values of x when y is minus 3. So where is y equals minus 3? Well, here's minus 2. Here's minus 4, so minus 3 is along here. And it's a simple matter of reading up to where it hits the graph, go down, or go up to the line and read off what that value is. Where it hits this line, go there and read off what the value is. And you can see that the teacher's done the line here, and they've done the line. It's a bit faint, but they have done it. And it's important that you do the same thing as well, because it's important to show your method, okay, how you got it. So that if your graph is wrong, okay, so listen to this bit. If your graph is wrong, okay, obviously in the exam you won't know whether it's right or wrong. Often you don't. Okay, but you still use it in the correct way. As long as you show what you're doing, you're probably going to get these marks. Okay, because if you didn't, the only reason it would be wrong is because your graph is wrong and you've already lost the marks for that. So it's like being punished twice for the same thing. So make sure you show what you're doing. In a sale, normal prices are reduced by 12%. The sale price of a digital camera is this. Work out the normal price of the digital camera. Now, what a lot of people do, and I hope you don't do it, is they say to themselves, okay, well, if we take 12% off, I just find 12% and add it back on. That won't make the right answer. All right, if you imagine we started with £100, if we take off 10%, we're on 90. And now if we put back on 10%, 10% of 90 is only 9, and we get to 99. So we took off 10% and we added 10%, but we didn't get back to the start. And that's because we took off 10% of 100, but only put back 10% of 90. So it's really important you work it out. This number here represents what the price would have been after 12% has been taken off. So this is 88% of the value. If you divide it by 88, you find out what 1% of the value is, and then multiply by 100, you get 100%. Okay, 151. Or you could say that this has been multiplied by that multiplier 0.88. That's what you would multiply by to reduce something by 12%. So whatever it was, whatever it used to be, it was multiplied by 0.88 to get this figure. So work backwards and divide this by 0.88 and you'll get the same answer. Okay, it's basically the same thing. Now, question 12 shows a tetrahedron, which is a four-sided pyramid, a pyramid rather, a four-faced pyramid, beg your pardon, and each of the faces are triangles. They don't have to be equilateral. And we've got a right angle here, and all these faces are at right angles. So we've got a right angle, right angle, right angle. So this line here is at right angles to here and to here, and these two sides are at right angles to each other. And we've got to calculate the size of the angle BDC, B to D to C. Now what you're going to use is the cosine rule, but at the moment we don't know any of the sides. So what we need to know is what this side is, what this side is, and what this side is. And what you need to do is picture the different faces of this tetrahedron, okay, in 2D. So if we look at, for example, the face on the bottom, it's a right angled triangle, okay, where we're trying to work out the hypotenuse of this right angled triangle. It doesn't look like a hypotenuse, but look where the right angle is. It's because of the perspective. This line here is the same as this line here, but by colouring it, you get an idea of what the triangle looks like. This is 8 and this is 10, and I can use Pythagoras to work out what that side is. Okay, and it will be, well, that's 10 squared and 8 squared, so it's there, and they've written it as the square root of 164. Now you could work that out as an actual number, and that would be fine, but it's a lot of numbers to write down really accurately. So often the square root of 164 is better than writing down a long decimal number. Okay, so this face here, if we saw it in 2D, would look like this. Here's your 10 and here's your 8. Here's your 10 and here's your 8, and this is the side here, here that we're trying to work out. Okay, in the same way, this side here is the hypotenuse of this triangle, this side face, where this is 5 and this is 8. So once again, 5 squared plus 8 squared equals that squared. That gives you 89, and once again they've left it as a square root of 89 rather than writing it as a long decimal. And lastly, you've got this length here, okay, which is the same as this triangle here, okay, so that's the longest side of a triangle here, this face that we can't see, this at the back that we can only see because we've got x-ray eyes, okay, this triangle here that I've shaded, where that is 5 and that is 10. So once again, 5 and 10, you've got 125. So by doing this, okay, you can see that we will have the answer to all three of these sides. So now we've got a triangle where this is the square root of 164, this is the square root of 125, and this is the square root of 89. Okay, and then you put that into your cosine rule formula. You can see here that the teacher has rearranged it, okay, to get the cos A all on its own, or you can do it in bits like we did in class. These should be squared, okay, so that's a little bit of a mistake there. This bit here and this bit here and this bit here, these should be squared, okay, because it's B is going to be, what is B? It's going to be 89, and that is there. And when you square it, so it's going to be the square root of 89 squared, which is 89. And this is going to be the square root of 125 squared, which is 125. So that's what you're going to get here. Okay, so you can write these as decimal numbers, but because it's a lot of working out to do and a lot of decimals to write down, it's often a good idea to just use them and leave them for the time being, at least in what's called surd form as a square root. Now, maybe you're not quite so good at working out this part, but look, you can pick up 3 marks for working out these sides. Okay? You can work out. So let's imagine you're in an exam. You've put your pen down. You've answered all the questions you can possibly work out. Okay? Have a go at doing this. Okay? What's the worst that could happen? All right? Work out some sides. Okay. A machine part is made by cutting a small square from the center of a large piece of steel. The dimensions of the machine part are shown in the diagram. The perimeter of the small square is 2/3 of the perimeter of the large square. Work out the length of a side of the small square. Right, so the perimeter of the big square is going to be 3x plus 4, 3x plus 4, 3x plus 4, 3x plus 4, or 3x plus 4 multiplied by 4. So 3 lots of that, I beg your pardon, 4 lots of that, 12x, and 4 lots of that, 16. 1 mark for doing that, okay? Before we've even solved it, I haven't solved anything at all. I've just written down an expression. I've already picked myself up a mark. Beautiful. The perimeter of a small square is going to be x plus 4, x plus 4, x plus 4, x plus 4. So 1, 2, 3, 4 x's, 1, 2, 3, 4 4's, 4x plus 16. So that's the perimeter of the small square, and that's the perimeter of the big square. And what we told? We're told that the small square is 2/3 of the perimeter of the large square. So how do you find 2/3 of something? You divide it by 3 and you multiply it by 2. So if we took the perimeter of the large square and found 2/3 of it, we get the same answer as the perimeter of the small square. So once again, a mark there. Now, the easiest way to solve this, rather than dividing that by 3, is to take this 3 over to here, where it becomes multiply. So 3 times 4x is 12x, and 3 times 16 is 48. So the 3 has now come up here. We've multiplied both sides by 3 effectively. We multiply here by 2. Okay. Well, actually, you can see what the teacher's done here is they have taken that multiplied by 2 and they've taken it over to here where it becomes divide by 2. That's another way of doing it. Okay. So half of that is 6x and half of that is 24. So we've got 6x plus 24 equals 12x plus 16. Put the letters on one side and the numbers on the other, and you get 8 equals 6x. So x is 8 divided by 6, which is the same thing as 4 over 3. Okay. Now, what does it say? It says work out the length of a side of the small square. Well, it's that we just worked out plus 4. Well, 4 over 3 is 1 1/3. Okay, 1 whole 1 1/3. If we add 4 to it, 1 1/3 changes to 5 1/3. Now maybe once again you didn't get so far as down to here. Okay, not for straight off at least. Oops. But you know there's marks to be picked up here by doing stuff that is fairly okay. You should pick up at least 1 mark for doing that. Carolyn has 20 biscuits in a tin and she has 12 plain, 5 chocolate, 3 ginger. Okay, work out the probability that they were not the same type. So first of all, look, 2 marks for just doing a tree diagram. Now with these questions, when we get onto the A* A questions, the probability changes. By that I mean it's not like rolling a dice where you've got a 1 in 6 chance every single time you roll it. Here, the first biscuit taken out was plain. So the probability is 12 out of 20 because there's 12 plain and 20 altogether. But now that biscuit's no longer in the tin. So the probability of getting a plain on the next go will only be 11 out of 19. All these probabilities are out of 19 because a biscuit has been taken out on the first go. But the probability of plain and chocolate and ginger next go will depend on what happened in the first time. So here, for example, the probability of getting a plain is 12 out of 19. And the probability of getting a plain here is 11 out of 19. Why is that? Well, here is the probability of getting a plain when you got plain on the first go. But here is the probability of getting plain when you got chocolate on the first go. So if the first biscuit was chocolate, There would be 19 left in the tin, but all 12 would be still in the tin of plain ones. Okay, so just by writing that out here, you picked yourself up 2 marks. Now, you want to work out the probability that the 2 biscuits were not the same type. Now, one way that would be a lot of work to do would be to say, okay, well, how can they not be the same type? I could have plain and chocolate, plain and ginger, chocolate and plain, chocolate and ginger, ginger and plain, ginger and chocolate. And each of those you'd need to multiply to get the probability of that happening. So, for example, plain and chocolate is 12 over 20 multiplied by 5 over 19. There's a lot of multiplying to be done, a lot of working out to be done. The quicker way is to say, right, well, the biscuits are either the same type or they're not the same type. So if I just find there's only 3 ways that they could be the same. 12 over 20 multiplied by 11 over 19. That's the probability that they're both plain. This 5 over 20 multiplied by 44 over 19 is the probability they're both chocolate. And this is the probability they're both ginger. Adding these probabilities up gives me the probability that the 2 biscuits were the same. If I take that away from 1, what's left is the probability that they are different, that they're not the same type. And that's less work. If you did it the way before, it would still work, but it would just take more time. So once again, this answer here makes that, and this is the probability that the biscuits were the same. Take it away from 1, and what's left is the probability that they're not the same. Question 15. The diagram shows an equilateral triangle. The area of the equilateral triangle is 36 square centimeters. Find the value of x. Now, if you know this formula, if you're looking at this booklet at a time when you know this formula, fine, by all means use it. But if you don't, you can still get some marks. First of all, we know that the area of a triangle is half the base times the height. Okay, now the base is x, but we don't know what the height is. But we can use trigonometry to work it out in terms of x. If we were looking for this, here's our hypotenuse, it's x, and the angle is 60. So, the area, I beg your pardon, the height of this is the opposite. This is the hypotenuse, so we're looking at sine. The height will be hypotenuse times the sine of 60. So that's what the height is in terms of x. The area of the triangle is half the base times the height. So it's 36, because we're told that's what the area is, and that must equal half of the base, half of x, times the height, which is x sine 60. Here it is here. So let's just work out what that is. It's going to be half x squared sine 60. Okay, get rid of that divide by 2, take it over here, it becomes multiplied by 2. You get 72. Get rid of that multiplied by sine 60. On the other side, it becomes divide by sine 60. So you get x squared is 72 divided by sine 60. And that gives you that answer. And this is x squared equals that answer. So then square root it and get 9.118. And there's your answer. Once again, you can get marks for picking up some bits. Even if you did that, you get a mark. Okay, doing bits of this gets you bits of the mark. It's worth having a go. Prove algebraically that the product of 2 odd numbers is always an odd number. Okay, so an odd number is 2 times a number minus 1. Okay, so any whole number here multiplied by 2, take away 1 is an odd number. So if you've got an odd and an odd, then you've got 2n minus 1 multiplied by 2m minus 1. They're 2 different odd numbers, so I've got different letters. Okay, if you multiply those 2 brackets together any way you like, you'll get 4mn, take away 2m, take away 2n plus 1. Just a quick check. 2n times 2m, 4mn. 2n times minus 1 is minus 2n. Minus 1 times 2m is minus 2m. And minus 1 times minus 1 is 1. Now, what have we got here? Well, we don't know what m and n are, but whatever they are, if you multiply it by 2, here or here, and here by 4, the answer is going to be even. So that is going to be even, that is going to be even, and that is going to be even. It doesn't matter what m and n are. They could be odd, they could be even, but as long as they're whole numbers, when you multiply it by 2 and by 2 and by 4, it's going to make an even number. So this part of this expression is even, and therefore if we add 1 to that even number, it will change it from an even number to an odd number, and that's as simple as that. A car is approaching a set of traffic lights. The traffic lights turn red. It takes the car 4 seconds to slow down to a stop. Here is the speed time graph for the 5 seconds until the graph stops. Now, work out an estimate for the distance the car travels in these seconds. Now, what we need to do is find the area underneath this curve. This part is easy, okay? This part, they traveled at 20 meters per second for 1 second, and so therefore the area of this is 1 times 20, 20. But it's a bit more confusing here, a bit more tricky, because the curve is a smooth curve, and we haven't got a formula for that curve, so we have to get an approximation by, you can see what this teacher's done here, they've drawn lines here to make it into some trapeziums. Okay, so here's a trapezium here, okay, and the height is 1. Imagine this trapezium turned over. Here's the base, and here's the top of the trapezium, and that would be the height. You just imagine that trapezium turned 90 degrees. Okay, now the formula for any trapezium is basically the average of the top and bottom, so the average of that plus that multiplied by the height. Okay, or another way of thinking it is top plus bottom multiplied by half the height. Okay, using that formula on each of these gives you, oh, here we've got a triangle, so that's going to be half base times height. Okay, you'll get an answer. What I've seen other people do, which is also fine, is they've drawn a bar. Say for example this part here, they've drawn a bar, okay, like that. Okay, so we are missing off this bit, but we're adding this bit here. Okay, and then we're drawing a bar here. Okay, and approximating this area to being roughly the same as a bar about that height. Okay, and that will work as well. Okay, that will also work. And then you've got to say, is your answer an underestimate or an overestimate of the actual distance? And that will depend on the method you used. So here, for example, what the teacher's done with these straight lines, is you can see that the trapeziums that he will be working out are going to have a little bit more area than actually is underneath the curve, because the line he's drawn or she's drawn are above the curve, so you're including a little bit more area, so it's going to be an overestimate. Yours might be an underestimate, so you've got to look at what you're doing. Okay, and you should have an answer of about that. Okay, you might not have exactly that, but it should be in that ballpark. A farmer wants to estimate the number of rabbits on his farm. On Monday, he catches 120 rabbits and he puts a tag on each rabbit. He then lets the rabbits run away. On Tuesday, the farmer catches 70 rabbits. 15 of these rabbits have a tag on them. Work out an estimate for the total number of rabbits on the farm. You must write on any assumptions you have made. So, what you've got here is, okay, so when he went out and looked at these rabbits once again, he caught 70 of them, and 15 out of 70 had a tag on them. So what you're going to assume is that that fraction is the same for the whole population. So if 15 out of 70 is the population, okay, so the reasoning here is this. When he caught the 70 rabbits next time, 15 rabbits have a tag on them. Okay, so obviously he's got to work out how many rabbits there are in total. Well, 15 he caught out of the original number of 70 is 21%. Okay, so basically he caught 21% of the rabbits he tagged before. Now that must mean in that case that the 120 would be 21% of the whole amount to make the fraction the same. So if there's 120 is 21%, dividing it by 21 21.4 as it was, gives you what 1% is. Multiply that by 100 and you get 560. Okay, and then it says, what assumptions have you made? Well, any decent assumption will do. You could say, I'm assuming that the rabbits haven't bred and increased in between the time of tagging them and catching them again, or they haven't died. Basically, there's the same number. Another assumption is that the rabbits that he tagged are now just uniformly mixed up with all the other rabbits. They're not all in one big group. Okay, he caught 120 rabbits, and those rabbits were all together at the time, I guess, when he tagged them. So you're hoping that they are now spread out uniformly among the whole rabbit population. So this question is actually fairly easy compared to the question number that you've got here, and it really is worthwhile, sticking in and trying to get some marks for every single question you can possibly get, because some questions, are just quite tricky and quite tough. But every now and then a question comes along where, it's right at the end, but you can have a go at it. Okay. Okay, I hope that video was helpful to you. If you still got any problems or questions on any of the questions that I've gone over, then please ask me and I'm happy to go over it one more time. Cheers, thanks folks, bye.